Look at your hand right now. Whatever shade it is, that color didn't come from nowhere. It's the result of one of the longest, strangest makeovers in the history of life on Earth, and it wasn't random. It was a survival story, a slow-motion negotiation between your ancestors and the sun. And the sun was not playing fair. The full answer involves vitamin D, cancer, folate, farmers who accidentally rewired their own evolution, and a star 93 million miles away that caused all of this and has zero regrets about it. Here's where it starts. Trace the human family tree back far enough, and every single one of your ancestors, no matter where you're from today, had dark skin. Around 300,000 years ago, when Homo sapiens first showed up in Africa, the entire species was dark-skinned. No exceptions. The concept of light skin didn't exist yet. Every civilization, every mythology, every ancient culture traces back to one founding population that looked nothing like a huge share of humans alive today. So somewhere along the way, something changed. To understand why, you need to know what skin actually does. It's not just packaging, it's your largest organ, and one of its main jobs is blocking UV radiation, the invisible energy the sun fires at Earth constantly. UV breaks chemical bonds, damages DNA, and causes mutations that, over time, can turn into skin cancer. The pigment that colors your skin, melanin, is in the most literal sense a built-in sunscreen. More melanin, more UV blocked, less DNA damage. That's why in equatorial Africa, under some of the most intense sunlight on the planet, evolution selected hard for dark skin. Natural selection doesn't care about aesthetics. It runs one calculation. Does this trait help you survive long enough to reproduce? Under the African sun, dark skin was an emphatic yes. But there's a second reason, one most people have never heard. UV doesn't just damage skin, it destroys folate, a B vitamin your bloodstream needs to build a fetus's neural tube in the first weeks of pregnancy, often before a woman even knows she's pregnant. Not enough folate, and you get neural tube defects or miscarriage. So dark skin in Africa wasn't just protecting against cancer, it was protecting pregnancies. Two independent threats, one solution. Dark skin wasn't just useful, it was close to mandatory. So if dark skin is this multi-purpose biological shield, why did it change at all? Starting around 70,000 to 100,000 years ago, groups of Homo sapiens began drifting out of Africa, generation by generation, eventually spreading through Europe and Asia. And as they moved north, the sun effectively got weaker, hitting the Earth at a lower angle, filtered through more atmosphere, blocked by overcast skies for months at a time. Suddenly, the cancer risk that made dark skin essential in Africa mostly disappeared. But a new problem showed up. Vitamin D, which your skin manufactures using UV light. Without enough of it, calcium doesn't absorb properly, bones don't form correctly, and in the days before supplements, that meant rickets in children and dangerously deformed pelvises in women trying to give birth. Put highly efficient UV-blocking dark skin in a gray, low-light environment, and it doesn't know the difference between UV it should block and UV the body desperately needs. It just blocks everything. So mutations that quietly reduced melanin started spreading, not because anyone chose it, but because in that environment, lighter skin kept more people alive long enough to have children. Here's the part that surprised even scientists. For years, the assumption was that this lightning happened gradually, over hundreds of thousands of years, as people slowly drifted north. Ancient DNA has completely blown that up. Early European hunter-gatherers were still dark-skinned, thousands of years after settling in Europe. The most famous example is Cheddar Man, who lived in Britain roughly 10,000 years ago. DNA analysis published in 2018 found he likely had dark to medium dark skin, with blue eyes. The pale skin we now associate with northwestern Europe only became widespread in the last 6,000 to 8,000 years, less than 3% of the total history of our species. So what actually caused the sudden shift? Agriculture. Hunter-gatherers ate fatty fish and organ meat, naturally rich in vitamin D. Farmers ate mostly grain. Their dietary vitamin D essentially collapsed, which meant their skin had to make up the entire difference. And farming communities were large and dense, which let a helpful mutation spread through a population far faster than it could in small, scattered hunter-gatherer bands. Diet change, plus population density, hit fast forward on a process that had been crawling along for tens of thousands of years. One more thing that should blow your mind a little. Skin color isn't controlled by one gene. It's controlled by dozens working together. In East Asian and European populations, both of which evolved lighter skin than equatorial Africans, mostly use different genes to get there. Two separate populations independently landed on the same solution through completely different genetic routes. When evolution reinvents the same trait from scratch more than once, that's about as strong a signal as biology gives you that the trait really matters. Blue eyes have a similarly wild backstory. Every person alive today with blue eyes descends from a single individual, one mutation, somewhere near the Black Sea, 6,000 to 10,000 years ago. Before that person existed, every human on Earth had brown eyes. Blue eyes are younger than farming, younger than Stonehenge. So step back and look at the whole picture. Skin color, the thing that shaped political systems and been used to divide people for centuries, is at its biological core a UV calibration dial. Your body's best estimate of how much sun protection you need, based entirely on where your ancestors happen to end up. Light skin isn't better. In equatorial Africa, it's a straightforward survival disadvantage. Dark skin isn't primitive, it's the ancestral, default human state. And lighter skin is the recent variation layered on top of it. We built an entire civilization's worth of hierarchy and prejudice on top of what is, underneath it all, a vitamin D problem and a folate problem. The same sun pushed some populations toward more melanin to survive its intensity, and pushed others toward less melanin because they needed more of its limited light. It never picked sides. It just radiated indifferently and let evolution sort out the rest. And that sorting isn't finished. Human populations are still evolving, just slowly enough that you'd never notice it happening to you. Every shade of human skin walking around today is a record, written in melanin, of exactly which environments someone's ancestors passed through to get here.